Factors are things that we multiplied together. Factored form is when we have a polynomial and it's written as a product of factors. We write it as a multiplication problem. Okay. Today we're going to work with polynomials that are already in factored form. And then after our quiz, we'll learn how to get them into factored form ourselves. Okay. So right now, standard form is what we've been dealing with. Okay, so maybe I have x squared plus 5x minus 24. Okay. Well, I'm going to now give you ones in factored form, which would look like this. A binomial times a binomial. Okay, so it kind of looks like the backwards of what we've been doing for the past couple days, right? Like I've been giving you this right here, and we've been foiling to get to standard form, okay? Well, we're going to work with factored form because it can help us solve, okay? So we have something called the zero product property. What happens when we multiply by 0?
0.
Does that ever change?
No.
I can take 1 times 0, 5 times 0, negative 2/7 times 0, 1,000,000 times 0. No matter what, anything times 0 is 0. Okay. So our zero product property says this. If I have two things multiplied together that equal 0. Since anything times 0 is 0, if I have two numbers multiplied together that equal 0, either A is 0 or B is 0. There's no other option. Okay. We are going to use the zero product property with a factored form of our polynomial to find roots. Have you heard that word in math before, roots? Besides square root, but with a graph, a root. Yeah? What'd you say? I mean, I kind of like, I can bridge that, the start, okay? Roots are a fancy name for the solutions to a polynomial. And what we're going to do to find them is we are going to set y equal to 0. Now, where on the graph does y equal 0?
At the bottom. The y equals 0 at the bottom. The origin. At the middle.
What do we call that? Not the origin, but other places too. What do we call that? M? The x-axis. Okay. So, I like where we start because we kind of, the x-axis is kind of our starting point when we go to graph things, okay? So our roots are actually where our graph crosses the x-axis. Okay, so when I ask you to find roots, I'm asking you, hey, where does this polynomial cross the x-axis? Okay. So this is what you might see. Okay, we're going to come down here where it says notes. We're going to do a couple examples here before we go to the next page. So I might give you something like this. X minus 3 times x minus 9 equals 0. Here I am giving you a polynomial that's already in factored form. Okay, what operation is in between right here? We have multiplication right there. So I have two different things multiplied together that equal 0. Well, what did we say about that? If I have two numbers multiplied together that equal 0, do you have something to say?
X equals 3 or 9.
Okay, you got it. You're a step ahead of me. Okay, so either this factor equals 0 or this factor equals 0. We take the two things that are being multiplied together to equal 0, and they both get set equal to 0. So like Theo said, if we solve this, if x minus 3 equals 0, then that means x equals 3. And if x minus 9 equals 0, that means x equals 9. So because we have two factors set equal to 0, we have two answers, two roots, if you will. Okay. Now what I'd like to do, I'm going to go into Desmos, okay? And I'm going to type in x minus 3 times x minus 9. And you don't know what this graph is, and you soon will. But what do you notice about this graph? We got the answers of x equals 3 and x equals 9, correct? Here's x equals 3. Here's x equals 9. It's where this graph crosses the x-axis. That's what we're finding. Okay. All right. What if we have one that looks like this? 2x times x minus 4 equals 0. All right, so do you notice, again, we have two factors separated by multiplication, right? And they're multiplying to equal 0. Well, if we have something multiplied together that equals 0, either one factor is 0 and or the other factor equals 0. Okay, so if I solve these, if I divide by 2, what do we get here? So x equals 0, and over here, x equals 4. Okay. Could you be more specific?
So like for like that part, so would we have to like plug those in for some reason to figure out?
Now we could like plug it back in to check our answer, and we should get 0 when we plug it back in, you know.
I'm just saying, but I don't think we'll ever encounter this, but if we were supposed to solve this to equal 0, to figure out how to get that to equal 0, is there any chance that we would do that? Or is that not even possible?
So I'm going to answer your question in one moment, okay, Joey? First, I want everyone to look at the graph. Notice the graph that I put up here. I typed in that equation that we started with, and it's hitting the x-axis here at 0 and here at 4, okay? Now, Joey, eventually I will give you something that looks like 2x squared minus 8x equals 0. And you will have to go from here to here and then do this, okay? But we're not going to worry about that yet. We're going to just focus on this right here, okay? What I want you to do, I want you to turn to the next page. And I am going to ask you to please solve for me number 1, number 3, number 4, and number 5. Okay? Work with your elbow partner. Doesn't have to be quiet in here, but I want you to see what you can come up with for those 4 problems. Have to be quiet. Except for you, Theo. Yeah. Thumbs up if you have all 4 of them done. All right, Willa, what do you get for answers for number 1? X equals 5?
Can you write them in like x equals like comma and 0 and comma, like not without negative?
-5. Like this 0, comma, -5?
Yeah.
That would be beautiful. I love it. Okay, 0 and -5, are we good there? Okay. All right. Number 3, if we set each of these equal to 0, Joey, what are our answers?
P would be 0 and P would be 2.
Good. Okay. Okay. And number 4, if you set each of these equal to 0, Theo, what do we get? 2 and -1. Okay. Those were all pretty straightforward. In 5, we had to think a little bit, right? If 2b minus 6 equals 0 and 3b plus 18 equals 0, here we're going to have to add 6, divide by 2. What do we get? 3. Okay. We would have to add the 6 over, then divide by the 2. Over here, we're going to subtract the 18 over, divide by 3, so we get -6, okay? Make sure that if we have coefficient here, that is going to affect our answer. Okay? Okay, however many factors you have, that's how many answers there are going to be. We're not like zeroed in on one type of polynomial, okay? So far, I've only done problems that have had 2 answers. But if we come down here to like number 12, how many answers are we going to have for number 12? We're going to have 3 because there's 3 factors. Ick. Let's try it out. We're going to have 4 minus m equals 0. We're going to have 8 plus 2/3 m equals 0. And we're going to have negative 2 minus 3m equals 0. If 4 minus m equals 0, what's m? M is 4. Okay, that's easy. Whew. All right, we can do this, guys. In this second one, we are going to need to subtract 8 to the other side. How do we get rid of the 2/3 that's being multiplied to m? And dividing by 2/3 is the same as? By its reciprocal. Okay? If we need to divide by a fraction, it's the same thing as multiplying by the reciprocal. So we have negative 8 times 3 divided by 2. What's that going to get us? Negative 12. Okay. And then our third one, if we add 2 over to the other side, we would then have to divide by negative 3. So 2 divided by negative 3, our third root would be negative 2/3.